Hi, my name is Stephen McGee and I'm the author of Toxic Light. I'm here today to look into one of the subjects of toxic light, and that is atmospheric pollution. And in front of us we have a fish tank, and in the fish tank we have water. As you can see, it's relatively clear right now. On the other side of the fish tank we actually have a halogen light bulb, and that's what we're looking at right now. So we can see we have a very white light coming through that water. So to simulate atmospheric pollution, we're going to start adding skimmed milk to the water to fill the water with particles, as that's what atmospheric pollution does. When we burn fossil fuels, we actually emit a large amount of particles and molecules into the atmosphere that start interfering with the transmission of light through the atmosphere. So let's start off and let's add a little bit of skim milk to the water and see what happens. So it's just a very, very small amount of milk that's being added right now. I'm stirring it up just to see what it does. And what I'm seeing now, instead of a white light, I'm actually seeing a yellow light. So that means the skim milk is actually starting to filter our light. So I'm going to add some more and let's see what we get. And just to let you know that the water actually has, rather than a milky appearance to it, it kind of has a little bit of a bluish tint to it. And that's caused by scattering of the light. And that's kind of why we get blue skies. So we just added some more. And we can see that as it filters through the tank, we're actually going from yellow to orange. So let's stir it up and spread it around. So it looks pretty even now. So when we look through it, we have indeed gone to orange light. So all our particles are acting like filters and are changing the colour of light. And basically what they're doing is they're actually extracting wavelengths of light. Some wavelengths are getting through and others aren't. And the removal of the wavelengths of light that aren't coming through has caused the light to appear orange. So let's add some more. Okay, so we've gone to a deeper orange with the extra particles that we just added. So basically what we're looking at right now, this is what happens at sunset. When the sun drops down to the horizon, we look through a large amount of air to view it, and all the particles that are in that air filter the sunlight and give us the yellow and orange sunsets. So let's add some more. So the water is actually looking quite white right now. And it's quite interesting to view it from the top because by the light it's very white, but over by the camera it's very orange. So there's definitely filtration taking place with the more mass of water that's in between the light and the camera. So we have a very deep orange colour to our halogen light bulb right now. It's quite an interesting sight to see the graduated colour. So I'm going to add some final milk and let's see what it gives us. So we're a very dark orange colour. So that's our sunset. So when you're watching the sunset, this is what happens. And unfortunately, as we're releasing more and more fossil fuel emissions into the atmosphere, we are actually going to see this effect occur in our own atmosphere, and it's going to occur sooner than it does now at sunset. And if it gets so bad, we may actually find that we may end up with a yellow sky in the daytime, which eventually goes to orange and may actually go to red. So this is why global warming and climate change and fossil fuel emissions are a really big problem, and it's a problem that we do need to address sooner rather than later. I hope you enjoyed this presentation, and I wish you the very best of health. Thank you.